Imagine being done with the GED Science test. Wouldn't that be a great feeling? Well, in this video, my goal is to get you one step closer to doing that. For those that don't know me, hi, my name is Parker from TestPrepChampions.com, and I want to help you pass the GED test. So I put together this GED Science Practice test. Now, this is just part one. We're going to do a part two very shortly, but I wanted to get this video out there for you so that you can get started making progress. Now, I once knew a student, and sadly, she suffered from child abuse, and due to being abused as a child, she had a lot of issues with depression and PTSD, and so she had to leave high school largely because of these issues, but she took 2 GED Science Practice tests. That's all she did to study for science. She just did 2 GED Practice Science tests, and she reviewed her results, and then she went in and she passed the real thing. That was all it took. And so I tell you this not just to tell you that all you should do is 2 practice tests. You might need more, you might need less, but I really want to emphasize just how powerful this can be for passing the GED test. And she's now enrolled in college for nursing, which is really amazing. So I share that just as inspiration for what you can do here. And I really want you to get the most out of this GED Science Practice test. Now, I've never done a science video before, let alone a science practice test like this, but I did write all these questions for a specific reason. These are questions that I think are most likely to show up on your exam, and this is from data analysis and from talking to students and from my own experience. I put this together for you. Like I said, we're going to do a part 2. I'll have that out very shortly. I really want you to make a commitment to go through this video. If it doesn't take you, if you can't do it all in one sitting, that's fine. Come back to it, or even double speed. Use the double speed button on your YouTube channel to get through this video. But I really want you to make that commitment to get through this, because commitment is required to pass the GED test. So let's get into this. Okay, first question here. Which of the following is supported by the data in the chart? Radon has a higher melting point than titanium. Titanium and magnesium are both liquids at room temperature. Titanium, magnesium, sulfur, and radon are all solids at room temperature. Or radon is a gas at room temperature. So I've given you a chart here, and you can go ahead and pause the video and try to figure this one out. Okay, let's go over how to do this one. So the key to getting this question right is to understand that there are 3 states of matter that you must know for the GED. Some people call these the 3 phases of matter, and some also call them the 3 stages of matter. Doesn't really matter what you call them, you just have to know that they are solids, liquids, and gases. And matter is anything that has mass or takes up space. So let's say that we start with solid, and I'm going to just abbreviate that with an S. And that solid can become a liquid, which I'll abbreviate with an L. And then that liquid can become a gas. So what do we call it when a solid becomes a liquid? A solid becomes a liquid, we call that melting. Now what about when a liquid becomes a gas? What's that called? You guessed it, when a liquid becomes a gas, we call that boiling. So with this established, let's go ahead and define both melting point and boiling point. So I'm going to abbreviate melting point as just MP, and I'm going to do the same with boiling point. I'm going to call it just BP. And so the melting point is the temperature at which the state changes from a solid to a liquid. In other words, it's the temperature at which matter melts. Now, the boiling point is the temperature at which the state changes from a liquid to a gas. In other words, it's the temperature at which something boils. Let's look at a really quick example of this using water. So if we look at ice, which is the solid form of water, we'll see that at the melting point, ice is going to start to melt and become water. The state of matter is going to go from a solid to a liquid. Now let's look at boiling. So I'm sure you've probably cooked something on the stove where you had to boil water before, maybe it was pasta, and so you take the water and it's a liquid and you apply a really high temperature and the water is going to start to boil and it becomes a gas. So there's a phase change from the liquid to a gas, and again, as I'm sure you know, that's what we call boiling. Okay, so with the context out of the way, let's turn to the question here. And so the question is one that you can solve by process of elimination. So let's go through all of these and let's evaluate each answer choice. So starting with A. Radon has a higher melting point than titanium. So this is pretty simple. We're just going to look at radon, which we see right here, and let me circle the melting point. It's -96. And we're going to compare that to titanium. So we see here that titanium has a melting point of 3038. So what's a bigger number, -96 or 3038? Well, hopefully you saw that titanium 3038 is a higher melting point, so therefore this is false. Radon has a significantly lower melting point, so I'm just going to cross A off up here so we don't get it confused. So let's look at B now. So B says that titanium and magnesium are both solids at room temperature. So first of all, what exactly is room temperature? So room temperature, which I'm going to abbreviate as RT, again, RT stands for room temperature, is about 70 degrees Fahrenheit. Okay, room temperature, RT, is about 70 degrees Fahrenheit. All right, and so we need to know if titanium and magnesium will be liquids, solids, or gases at room temperature. So let's look at the melting point here. And the reason we want to check the melting point is because the melting point is the temperature at which the state changes from solid to liquid. So let's start there, and we see that the melting point for magnesium is 1202 degrees Fahrenheit. Okay, so again, the melting point is the temperature at which a solid becomes a liquid. So we know that at 1202 degrees, magnesium will go from being a solid to a liquid. All right, so at 70 degrees is well below 1202. So we know that magnesium is going to be a solid at room temperature. So this whole thing is false. We don't even really need to check for titanium, but just for fun, let's look at titanium. So we see that, again, the melting point for titanium is 3038. And what does that really mean? Well, again, the melting point is the temperature at which a solid becomes a liquid. So at 3038 degrees Fahrenheit, titanium will go from a solid to a liquid. And so if we put titanium in a room at about 70 degrees, that's not going to be anywhere near the melting point temperature, right? So 70 degrees is much lower than 3038. So titanium is going to be a solid, and so therefore that B is completely false, that they are both going to be liquids at room temperature. They're both going to be solids. Let's check answer C now. So titanium, magnesium, sulfur, and radon are all solids at room temperature. Well, are they? Well, we already know that titanium and magnesium are both solids at room temperature because they have melting points that are higher than 70 degrees. Again, 70 degrees is about room temperature. Now, sulfur's melting point is 239, which is higher than room temperature. So therefore, at room temp, sulfur is going to be a solid. Now, what about radon? Well, we see that radon's melting point is negative 96. Therefore, at negative 96 degrees, radon is going to melt. So in other words, at negative 96 degrees, radon goes from a solid to a liquid. Then at negative 79 degrees, we see that radon is going to become a gas. Therefore, radon will boil. It'll go from a liquid into a gas. So a note here that negative 79 is a bigger number than negative 96. So which would you rather owe? Which would you rather owe? Say your credit card statement comes in. Would you rather it be negative 96 or negative 79? Well, obviously negative 79, because that would mean that you owe less money. All right, so just keep in mind that negative 79 is actually a bigger number than negative 96. And so, therefore, answer D is actually going to be the correct answer because we know that radon will be a gas at room temperature. So hopefully this question makes sense. Question 2 says, carbonic acid molecules are composed of 2 hydrogen atoms, 1 carbon atom, and 3 oxygen atoms. Water is also composed of hydrogen and oxygen, but water has 2 fewer oxygen atoms than carbonic acid does. Carbon dioxide molecules are composed of 1 carbon atom and 2 oxygen atoms. Which of the following statements best describes the chemical reaction represented by the equation below? And we see this chemical equation here, and we've got answer choices A through D, so go ahead and pause the video and take a stab at this one. Okay, so let's go over this. And this is one of those questions, like many on the science, that seem hard at first, but once you see how to do it, this is actually a very easy question. It just might make your eyes gloss over when you first read it. So first of all, let's go over some basic terminology. So you see the word atoms popping up here. What are atoms? Well, atoms are just, for the GED test, know that atoms are the smallest particle of matter. And note that atoms can combine to make molecules. And so the first thing that we can do here is we can define what's going on in our chemical reaction. Okay, so this chemical equation right here represents a chemical reaction, and you can almost think of this like you would an equation in mathematics, because the number of atoms on the left-hand side and the number of atoms on the right-hand side are equal, which I'll show you in just a moment here. But for now, just keep in mind that the difference is that everything that's going on the left-hand side, which would be, here's our arrow, so the left-hand side is everything to the left of the arrow, and everything on the left-hand side is what we're going to call reactants. All right, and this is really important to remember, that what's on the left-hand side of the equation we call reactants. So let me write that out here, and hopefully my handwriting helps you remember that everything on the left-hand side of the equation is the reactants. And now everything on the right-hand side of the equation we call the products. All right, and so again, my handwriting here hopefully is so bad that this will be memorable enough for you to remember that what's on the right-hand side are the products. Okay, so left-hand side of the reaction, reactants, right-hand side of the equation are our products. Okay, and that's very, very important to remember. All right, and so you can think of it like this way. Like, let's say that you're making an omelet, for example. So what do you put into an omelet? Let's say you've got eggs, which I'll just abbreviate with an E. Let's say you put some spinach in. I'll abbreviate that with an S. Let's say you take butter, and maybe you put in some cheese, which I'll just put with a C here. So you've got eggs, you've got your spinach, you've got butter, and you've got some cheese, and you put them all in a frying pan and you add some heat. And I'm going to make a triangle here that shows heat, and you heat them up, and what do you get? You get an omelet, all right? You get an omelet. All right, and so here what's going on is that you've got your eggs, your spinach, your butter, your cheese, all these ingredients, and they're going to react and they're going to produce an omelet. So remember, again, everything to the right of the arrow, the right-hand side of our equation is the products, and everything on the left-hand side is going to be the reactants, okay? And so that's very important to remember here. All right, so next, let's just identify what's really going on here in the question. So I'm just going to give us some room to write here. Let me get this out of the way here. So hopefully you got that in your notes. And so let's identify what's going on here in the question. So carbonic acid molecules are made of 2 hydrogen atoms, 1 carbon atom, and 3 oxygen atoms. So what we see here is that this H2CO3, this is our carbonic acid. So let me abbreviate that with Ca. And we know that that's carbonic acid because just like it says up here in the question stem, it says there's 2 H atoms, 1 C atom, and 3 oxygen atoms, which we see here. So we see 2 H, we see 1 C, and we see oxygen, and we see this 3. Now you might be wondering what these little numbers are down here. Well, those are called subscripts. All right, the little numbers here are called subscripts, and they just tell you how many of that atom there are. So for example, there are 2 hydrogen atoms or 3 oxygen atoms, but when you don't see a subscript, you just assume it's 1, so we'd say that there's 1 carbon atom. So this is our carbonic acid. So if we keep reading here, we see water is also composed of hydrogen and oxygen, but water has 2 fewer oxygen atoms than carbonic acid does. So how many oxygens does water have? Well, it tells us that there are 2 fewer than carbonic acid. Carbonic acid has 3, so 3 minus 2 is 1, so we know that water is going to have 1 oxygen, and it's composed of hydrogen, right? And it doesn't tell us how many hydrogens there are, but I'm going to tell you right now that water is H2O. You've probably heard that before, like if you've seen the movie The Water Boy or other movies, or just from common knowledge, you probably know that water is H2O. All right, so let me just put a big W here just so we remember that water is H2O. Then lastly, we're left with CO2, which is carbon dioxide. And if you didn't know that was carbon dioxide, you can know because it tells us that carbon dioxide molecules are composed of 1 carbon and 2 oxygen atoms. So we see here, again, 1 carbon. We don't see a little number down there, so we just assume it's 1. And we see 2 oxygen atoms, right? And so we see oxygen, which is represented by this O, and we see the subscript has 2. All right, so we know that this is going to be our carbon dioxide. So let me just put CD for carbon dioxide. So we've now identified what's going on here. So again, what are the products? Well, the products are water and carbon dioxide. And what are the reactants here? Well, we've only got 1 reactant here, which is our Ca, which is carbonic acid. Okay, so with some basic stuff laid out here, what I want to do is now go through answer choices A, B, C, and D. But actually, you know what, there's one more point that I want to mention here, and that's the law of conservation of mass. And this is very, very, very important to understand. So let me put that right here. Hopefully you can read that okay. This is very important. So the law of conservation of mass states that matter is neither created or destroyed in a chemical reaction. And I abbreviated reaction as RxN to save space. So the mass of the products always equals the mass of the reactants. All right, so the mass of the products here, which again, products are the right-hand side of the chemical equation or chemical reaction, whatever you want to call it, and the reactants, or in this case, we just have 1 reactant. The reactants are on the left-hand side of the equation, okay? And we get that from the law of conservation of mass, which says that matter is neither created or destroyed in a chemical reaction, and thus it follows from that that the mass of the products is always equal to the mass of the reactants, all right? And so it also follows from this then that the number of atoms is going to be conserved. So the same number of atoms that you see on the left-hand side of the reaction must also be present in the right-hand side of the reaction. So if we count these up here, we see that we've got 2 hydrogen atoms, we've got 1 carbon, and we've got 3 oxygens on the left-hand side of the equation. So if we go over here on the other side, we see that we've got 2 hydrogens, we've got 3 oxygens, right? Because we've got 1 oxygen here, we've got 2 oxygens here, 2 plus 1 is 3, we've got 1 carbon. So again, we see that the total number of atoms is the same on the left-hand side and the right-hand side. And again, we know that that should be correct because of the law of conservation of mass. Okay, so Now, this is just some basic understanding that's crucial to get here, and we'll look at some how to balance chemical reactions. There'll be a question on that down the line here, so this is some basic background stuff that you'll want to know to not just get this question right, but also to get that question right as well. But I also just want to point out here one last thing, that these subscript numbers here, you never change those. So down the line, when you've got to balance chemical reactions, you never, ever, ever, ever change those subscripts. Okay, now you can change the coefficients, and in this case, we don't see any coefficients. The coefficients are just 1, right? So the coefficient would be like a number out front of here. So you could have like 2 CO2 or maybe 3 H2O. So the coefficient would be the number that is in front of the molecule. So let me get rid of those here. Since we don't see one here, we just assume it's 1, right? So we just assume that there's 1 CO2 or 1 H2O molecule or 1 H2CO3. Okay, but those numbers out front, you can change those when you're balancing reactions. But the subscripts, those little numbers down here, you never change those when you balance chemical reactions. Okay, so just keep that in mind here. So let's get into this here. So A is water is reacting with carbon dioxide to make carbonic acid. So is that true or false? Well, what's reacting here? Well, the only thing, what are our reactants? Remember, the reactants are everything on the left-hand side of the equation, which is carbonic acid. So the only thing that's going to react here is carbonic acid. Okay, so water is on the right-hand side of the equation. Water is a product. Water is being produced. So water is not reacting with carbon dioxide to make carbonic acid. Okay, so again, the products are, where it says to make carbonic acid, that would imply that we're making carbonic acid when really we're not. Carbonic acid is actually decomposing into water and CO2, and so really that keyword reacting can really knock this one out, knock answer A out for you here, right? Because reacting, water is not reacting, water is being produced here. So B, carbonic acid is decomposing into water and CO2. I just gave that away. B is the correct answer, but let's just briefly look at why C is wrong and why D is wrong. So C, carbonic acid is decomposing into pure water. So pure water would imply that the only thing that's being made is water. Here, that's what I would take away from that. But, you know, there's different kinds of water, like distilled water, but that's not what you need to know here. The point here is that, you know, we also see that carbonic acid is decomposing into water, but also into CO2. All right, and so C is therefore wrong. And we also see that with D, it says carbon atoms were created during the reaction, resulting in more carbon atoms in the product. And if you were just listening when I talked about the law of conservation of mass, we know that matter is neither created nor destroyed. Therefore, the mass of the products must always equal the mass of the reactants. So just based off of that, we know that carbon atoms were not created during the reaction because matter is never created, it's never destroyed. All right, and we also know that it's not possible for there to be more carbon atoms in the products. All right, and so if you didn't know this law of conservation of mass, you could just look at the second part of the question here where it says resulting in more carbon atoms in the product. You could just count them up. You could say, well, we've got on the product, again, remember, everything to the right hand side of that arrow is a product. So we see that we've got 1 carbon atom here. And then you look on the left-hand side and you say, well, there's 1 carbon atom there. Again, how do we know that there's only 1 of each? Well, we don't see a little number down here, so we just imagine that there's a 1 there. Okay, we don't write the 1, but we imagine there's 1. So we see that on the left-hand side of the equation, in our reactants, there is 1 carbon atom, and in the right-hand side of the equation, we see that there is 1 carbon atom here as well. So we would know that this is bogus, all right? So D is incorrect. So you can either get D by knowing the law of conservation of mass, or you can just reason your way through it. All right, but B is our correct answer here. So question 3 says, the standard heat of combustion is the energy released when a substance undergoes combustion with excess of oxygen at standard conditions. A scientist wanted to determine the performance of various fuels in a power generation turbine. She determined the standard heat of combustion for 5 chemicals. However, she lost the data for chemical 4. And then it says down here, the mean value is 2008.2. What was the heat of combustion for chemical 4? And as you can see here on the chart, we've got 5 different chemicals and heats of combustion, and we see that for number 4, we are missing that, and that's what I want you to find. So go ahead and pause the video and try this out. Okay, hopefully you had a chance to take a stab at this. So many questions on the GED Science test are going to appear a lot more complex than they actually are. So just keep that in mind, that there's usually, whenever you see something that seems really complicated, there's usually some way that you can kind of reason your way through it, or there's usually something behind it that they want you to get. And in this case, what we need to see is this word mean. So this word mean is like a huge cue to what we have to do to solve this question here. So the word mean means the average, all right? And that's really important to know. So
mean equals the average. All right, mean just equals the average, and I'm just going to abbreviate average as AVG. So the mean means the average. All right, and so if you remember from math, if you've gotten into your math studying at all, you might know how to do mean, median, mode, and range problems. All right, so if you know how to do that, then what we want to do here is we want to use a strategy involving finding the mean. Okay, but we're actually given the mean. So I'm going to show you how to do this here. So how would you find the mean? So the way you get the mean or the average is you take all of the numbers in a data set, you add them up, and then you divide by the total number of numbers in that data set. So let me show you what I mean here. So what we're going to do is we're going to take all of the numbers in our data set. So the data set here is just chemicals 1 through 5. So we're going to take the heats of combustion here, and to get the mean, we would add up all of the numbers in that data set. So we've got 1167, and we've got 3393, and then we've got 3268. All right, so we add that up here. We've got 3268, and then we've got a question mark, right, because we don't know what that is. So let me put that down here. So let's say that we've got our question mark, okay, and I'm going to add that here. And then we're also going to add 1527, okay? And so hopefully what you see here is that all we're doing is we're taking all of these numbers, right? I got this 1167 here, and I've got our 3393, okay, and then 3268, right? So hopefully you see what I'm doing here. So let me clear these out of the way. But we're just taking all of these numbers in our data set, all right, and we're going to add them up. And so we don't know what number 4 is right now, so I just put the question mark there for 4, okay? And so now we're going to count up the total number of numbers in our data set. So here, let's make a tally here. So we've got 1167, so that's 1. We've got 3393, that's 2. We've got 3268, that's 3. We've got our unknown, that would be a 4th. And then we've got 1527, so 5. So there's 5 numbers in our number set. So we're just going to divide this all by 5, okay? And that, in theory, is going to give us our mean, okay? But what's the problem here? Well, the problem here is we don't know what this question mark is, okay? But fortunately, let me cross this out here. Hopefully you got that in your notes. Fortunately, we already do know what the mean is here, okay? And we know that the mean is 2088.2, okay? So we know that this whole equation here, right, if we add up all the numbers in the data set and divide by 5, it would give us 2088.2, okay? And so now what we're going to do is we're just going to treat this like an algebraic equation, all right? And what I mean by that is hopefully you've been into your math studying already, but if not, that's totally fine. I'll show you how to do this here. So what we're going to do is we're just going to take all these numbers here and we're going to add them up here, okay? And we're going to treat this exclamation or this question mark as a variable, and a variable is just another word for unknown. Okay, so what I want you to do, if you didn't do it already, is just add the numbers up on the top here. So we'll do 1167 plus 3393 plus 3268 plus 1527, and I'm doing that in my calculator as we speak along with you. Okay, so the answer is we've got 9,355. All right, so let's rewrite this now. And so we've still got our unknown, so let me just leave that as our question mark. So we've got our question mark plus 9355, all divided by 5. Okay, and this is equal to 2088.2. Okay, so now what we want to do is we want to isolate the variable. So in any algebraic, this is like an algebraic equation. Okay, so we want to get this variable alone on the right-hand side of the equation. Okay, to the right of the equal side is the right-hand side of the equation. So the way that we're going to do that is we're going to look at this 5 here, all right? And so we see that everything here in the top part of the fraction is called the numerator, which is our question mark plus 9355. This is all being divided by 5, okay? So we want to do the inverse operation of division, all right, which is multiplication. So let's multiply by 5 here. And the reason we're going to do that is because that's going to cancel our 5 out, because 5 divided by 5, right, is going to be 1. All right, but whatever we do to one side, we've also got to do to the other side. So if we multiply by 5 on this side, then we've also got to multiply by 5 over here. All right, so I'm putting this in my calculator right now. We've got 5 times 2088.2, which is going to give us 10,000. We've got 10,441. and that's equal to our unknown plus 9355. All right. And so now what we want to do is, again, the big strategy here is we want to get this question mark alone by itself on the right-hand side of our equation. Again, here's our equal sign. Everything to the right, everything over here is the right-hand side of the equation, and everything over here to the left of the equal sign is the left-hand side of the equation. So we want to get this question mark by itself on the right-hand side of the equation. So what do? Well, we see that we've got the question mark plus 9355. So we want to clear this 9355 out of here. So what we want to do is we want to do the inverse operation, also known as the opposite operation. So the opposite or the inverse of addition is subtraction. So we want to subtract 9,355. All right, and so why do we want to do that? Well, 9355 minus 9355 is going to be 0. So all of this will be cleared out, and we're going to be left with this question mark here. All right, and so there's one catch here though. Whatever you do to one side, remember you always do to the other side. Okay, so now we've got this 9355, and we are going to have to subtract. All right, so let me put this in my calculator, and we see 9355. And we're going to be left with 0, or we've got 1,086. We've got 1086, all right? And that's going to be the answer here. So the heat of combustion for chemical 4 is 1086, okay? And so basically what we had to do here, let's just do a quick recap, right? So that's our answer here, our 1086. We just had to understand how to get the mean, and you get the mean by you take all these numbers in the data set and you add them up, and then you divide by the total number of numbers. So from here, if we wanted to check this, which I'm not going to do for the sake of time, but if we wanted to check it, we would just take all of these numbers here, all right? We would line them all up, and then we're going to add them up, and then we divide by 5 because there's 5 numbers in the number set, right? 1, 2, 3, 4, 5. All right, and we do that, and then that should give us 2088.2. All right, but in this case, this question, this wasn't really just an example of finding the mean. We were given the mean, and we were given a data set, but one of the numbers in the data set was missing, so that's why we had to do this. But these mean, median, mode, and range questions are quite common on the science section, so I do recommend you check out my video on mean, median, mode, and range. I show you some more examples of how to do this, but just quickly, if we wanted to find the range in this data set, to find the range, what you do is you just take the biggest number in the data set and the smallest number, and you would subtract them. So the biggest number here looks like 3,393, and so we would just find the smallest number now, which is 1086, and we'd subtract them, all right? And I'm not going to do it just for the sake of time. We don't really care, but I'm just showing you this is how you would find the range. All right, you just take the biggest number in the data set and the smallest number, and you subtract them. That's how you get the range. So we know how to do the mean. We know how to do the range. Now, what about the mode? Well, in this case, we don't see, all the numbers just appear once, so we don't see a mode here. The mode is the most occurring number, all right, but really they all occur one time here, so the mode is not something we're going to worry about here. All right, so we have the mean, median, and what about the median? So in order to get the median number, what you need to do is you need to order the numbers from smallest to greatest, and then you look at the middle number. All right, so we can do that quickly here. We would do 1086, and I'm just ordering these from smallest to greatest, and then the next greatest would be 1167, and I'm just doing this to show you how you would get the median very quickly here, and then our 1527, okay, and then we have 3268, and then the biggest number is 3393, and that is a 9. So let me get this out of the way here. So we're just looking at this here. So now we just look at the middle number, all right? So the middle number is 1527, so that's just going to be your median. So again, the median, you've got to order the numbers from smallest to largest, and when the numbers are ordered from smallest to largest, the middle number is your median. Okay, but now let's say if that only applies though when you've got an odd number of numbers in the data set like we do here. Okay, if you don't, then what you have to do, like let's say that we didn't have this number here. Let's say that there were only 4 numbers in the data set, and we just had 1086, 1167, 1527, and 3268. Then what would we do? Okay, then we would have to take these 2 numbers, all right? So you would take the 2 middle numbers, you would have to add them up and divide by 2, right? So you would have to do 1167 plus 1527 2, 7, and then you would divide that by 2, and that's how you would get the median if we'd only had 4 numbers in the data set. So if there's an even number of numbers in your data set, you've got to take the 2 most middle numbers and you've got to take the average of them. And you take the average of them by, you add them up and you divide by 2, okay, and then that would be the median. Now, if you've got an odd number of numbers in your data set, it's very easy to find the median. You just have to arrange them first by smallest to largest and then whichever number is in the middle, okay? And so that's how we would do number 3, and that's a bonus quick little lesson on mean, median, mode, and range, which that's very, very important to know for the science test. Those questions do come up often on GED Science, and this is also something that you would have to know for the math test as well. So I'll put a link down below if you want to learn how to do mean, median, mode, and range. I've got some more examples in another video. All right, so let's keep moving. Okay, so now for questions 4, 5, and 6, we're going to use the following paragraph and diagram. So let me read this and then I'll let you go ahead and take a stab at number 4. The following Punnett square shows all the possible combinations of alleles for color and offspring pea plants when 2 color hybrid pea plants are crossed. A capital P represents the dominant color, or the purple allele, while a lowercase p represents the recessive color, the white allele. One parent's alleles are seen on the left-hand side of the square, and the other parent's alleles are seen on the top of the square. So what we see here is this is a capital P, okay, and this is a lowercase p. This is a capital P, that's a lowercase p, and basically we see these alleles here, and the genotypes of the offspring are shown in the boxes. And so if you want to grow purple pea plants in your yard this year, which of the following genotypes would you want? And you see a short list here in answers A through D. So go ahead and pause the video and try to take a stab at this one. Okay, so just a heads up, my kitty cat just jumped up in my lap and I don't really want to kick him off, so I apologize if there's any noise picked up on the mic for that, but it is what it is. So anyway, I'm not going to put all the definitions for this question up on the board here because it's just going to take too long and it's going to take up too much space, but I put a word bank here, so if you're taking notes, you can get these down as I'm going to talk about these briefly. And I'm going to talk about these briefly, and then that's going to make questions 4, 5, and 6 go pretty quickly, but I do want to get this stuff out of the way here. So basically, the idea here is that all species of organisms have to procreate in order to keep the species from going extinct. If humans stopped having babies altogether, we would go extinct eventually after everybody died off because there would be no new humans being born to take our place. All right, and there are 2 different types of reproduction. There's asexual and there's sexual reproduction. Now, asexual reproduction is reproduction in which the offspring produced are identical to the parent. So just consider plants, right? The offspring produced by plants are identical to the parent. Now, this is not the case with humans, right? So with humans, we have sexual reproduction, and I'm sure you know what that is. If not, you can Google it. Okay, that's just a joke. I'm sure you do know what that is. But anyway, when we define the word heredity, what we're talking about is the passing of traits from parent to the offspring by sexual reproduction. So again, heredity is the passing of traits from parents to the offspring by sexual reproduction. And traits are really genetically determined characteristics. They're physical characteristics that are determined by our genetics. And we can define the word gene as a unit of heredity which is transferred from parent to offspring. All right, so we define heredity as the passing of traits from parents to the offspring by sexual reproduction. What's being passed on is these traits, but what are genes? These genes are the units of heredity that are being transferred. All right. And so we can also define a word called alleles. And alleles are different forms of a gene. And so the difference between genes and alleles can be a little bit confusing, but basically think of it this way. So the gene that, in this example here, right, the gene that controls pea plant color, that's the gene, but the alleles could be for purple and white. And in this case, we have an allele for purple and an allele for white, but the gene is controlling the plant color. All right, so hopefully that makes sense here. But anyway, each pea plant is going to inherit one allele from each parent. Okay, and if at least one dominant allele is inherited, then that individual is going to show the dominant trait or the dominant phenotype, we could say. All right, and the phenotype is just the set of observable characteristics of the individual, and these, again, the phenotype, it's like you can think of it as observable or physical characteristics, whereas the genotype is the genetic makeup of the cell. And again, if at least one dominant allele is inherited, the individual will show the dominant trait, and for a recessive trait to appear in the individual, though, the individual must inherit 2 recessive alleles. And I'm going to show you what this means here in a minute. Okay, so with the background out of the way, this is probably the most important thing you've got to understand. So when we're talking about dominant and recessive, okay, what that means is that whenever there's a combination of alleles where there's at least one capital P okay, there's going to be a purple phenotype. So we see here that if the parents' alleles combine and we get the combination of a big P and a big P, we're going to have a purple flower. Now, if we get the combination of a big P and a little p, okay, we're still going to get a purple flower, okay, because remember, as long as there's a big P in the combination, the flowers are going to be purple. All right, now the only way you can get white is with two little p's. All right, and we see that in this combination of alleles. So parent 1 contributes a little allele and parent 2 contributes a little allele. So little p and a little p equals white. So in any other case, as long as there's a big P, it's going to be purple. All right, but if there's two little p's, then it's going to be white. So it says here in question 4, if you only wanted to grow purple pea plants in your yard this year, which of the following genotypes would you not want? And the word not is really key here, okay, because big P, little p, big P, all right, you're usually not going to see it written as little p, big P. It'll usually be big P, little p, but they might try to trick you up because it's really the same thing. All right, so any answer choice here with the big P is going to give you purple, which is what you want. So if it's asking us which of the following genotypes would you not want, all right, if you want them all to be purple, you don't want little p, because that's going to give us white. So C is the answer here. All right, so question 5 here, everything is the same, the beginning is the same. I underlined this P here just to make it look more like a little p, but this whole first part of the question is exactly the same. We just need to find the probability that the offspring is going to be white, which I have here, and we see the probability is equal to the total number of favorable outcomes divided by the total number of outcomes. I've given you that formula. Go ahead, pause the video, and try this out. Okay, hopefully you had a chance to try this. So all we're doing here is very simple. We're going to plug this into the formula. So we want to find the total number of favorable outcomes. And here that favorable outcome is having a white offspring or a white flowered plant. All right, and there's only one chance that that can happen here. So the only way we can get that white offspring is if we've got that combination of the two lowercase alleles, all right, or the two recessive alleles. Okay, so the total number of favorable outcomes is going to be 1, and the total number of outcomes is 4, right? Because we can see here in our Punnett square that there are 4 different combinations of alleles. We've got big P, we've got one big P from one parent, one big P from the other, so we've got big P, big P, big P, little p, big P, little p, and a little p, little p. All right. Now the big P, little p is called the heterozygous condition, and the little p is called the homozygous recessive. It's recessive because it's little p. It's homozygous because there's 2 of the same allele here, and the big P we would call homozygous dominant. Dominant because there's 2 of the dominant allele. Homozygous because there's 2 of the same allele. Okay, just some terminology. Not super important to know that, but I just wanted to point that out here. So you know when I'm saying big P, little p, that's not the scientific terms for it, obviously, but you get my point here. So the point here is that we've got 4 outcomes total, and we've got one outcome of it being white. So we do the math here. We see 1 divided by 4 is going to be 0.25, or we could express that as a percent as 25%, but there's no need to because that's not what the answer asks us. But it's just simple. Answer A is going to be the right answer here. Now let's move on to question 6. Okay, so now we're on to 6, which is the same type of question. Everything's the same except now the question is asking what is the probability that the offspring will be purple? So go ahead and pause the video and try this one out. Okay, so here we go. Let's get right into this one now. Again, we're going to use that formula for probability, but this time the total number of favorable outcomes will be the total number of purple offspring, all right? And so there's 3 different cases where we could get purple, right? The big P, little p, big P, little p, those are all going to give us purple. So we see 3 favorable outcomes, and there are 4 total. Again, there's 4 because we've got all these different combinations here. We see 4. All right, and again, like I just said literally a minute ago, big P, little p, that's just what I call it because that's what makes it easier to follow here, but those aren't the scientific terms. But don't worry about the scientific terms too much. I just want you to get the concept here. And if you do the math, 3 out of 4 is equal to 0.75. So there we go. C is going to be our answer. All right, so hopefully this all makes sense. Okay, question 7. Below is the chemical equation for photosynthesis in plants. And we see the equation right here. And then it says, which of the following is correct based on the information given in the equation? Water and carbon dioxide are produced as a result of photosynthesis. Sugar and oxygen are the reactants in photosynthesis. C, carbon dioxide and water are the reactants in photosynthesis, or D, light energy is not involved in photosynthesis. Okay, so go ahead and pause the video and try this out on your own. All right, so let's get into this now. So basically, what we want to do here is let's go down A, B, C, and D, and let's try to determine if each of the statements is true or false. So let's look at A first. Water and carbon dioxide are produced as a result of photosynthesis. So what's being produced in the reaction? Well, it's actually the sugar and oxygen, all right? So let me label this as a P to show that these are our products. So remember, in a chemical equation, everything to the right of the arrow on the right-hand side of the equation, that is going to show the products, okay? So these sugar and oxygen are the products which I've abbreviated with a P. Now remember, everything on the left-hand side of the arrow are our reactants, which I'm going to abbreviate as an R. So these compounds over here, these molecules on the left-hand side of the reaction are reacting and they're producing sugar and oxygen. So we know that A is false because it says water and carbon dioxide are produced as a result of photosynthesis. No, the sugar and oxygen are produced. B, sugar and oxygen are the reactants in photosynthesis. Well, again, we know that the reactants are carbon dioxide and water and not sugar and oxygen, so we know that B is also incorrect. So C says carbon dioxide and water are the reactants in photosynthesis. Carbon dioxide and water, yes. So this is actually the correct answer. And let's just go over D though as well here. So D, light energy is not involved in photosynthesis. Well, hopefully you could see right here that yes, light energy is involved in photosynthesis. So D is incorrect. So basically what's going on here in photosynthesis is in plants is that there's carbon dioxide from the air and that combines with water, and in the presence of sunlight it's going to produce sugar. Okay, and oxygen is also produced, but it's given off as a waste product. So the primary product here is sugar, but yes, oxygen is also given off during photosynthesis. Okay, question 8 says that the data in the table below represents the highest daily temperature in Hawaii measured over a 4-day period. And it says, what was the temperature on day 3 measured in degrees Celsius? And yes, you can use a calculator on this question. All right, so go ahead and pause the video and you can try this out on your own. Okay, so hopefully you had a chance to try this out, and like I said, you can use a calculator on this one. All right, and so let's get right into it here. So all we're going to do is we want to look at the temperature on day 3, which is in degrees Fahrenheit, that's 87, and we're going to take the formula and we're just going to plug 87 in here for degrees Fahrenheit. So temperature Celsius, which I'm just going to write as T with a little c here, that's equal to the temperature in Fahrenheit, which is 87 minus 32, and then multiplied by 5 over 9. All right, times 5 over 9. And so now, when you do math, right, I'm not sure where you're at with your math studying right now, but you want to follow what's called the order of operations, or PEMDAS. Okay, please excuse my dear Aunt Sally. And what the P stands for is parentheses. So you always want to start off with what's in the parentheses here when you're doing multiplication or division or any kind of operations. These are our order of operations rules. So before you would try to do anything else, we want to first deal with what's in the parentheses. So 87 minus 32, if you plug that into your calculator, that's going to be 55. So we have 55 here, and we now have 55 times 5 over 9. All right, so you could do this in a couple different ways. You could do, there we go, this is a 5 here. So you could do 55 times 5 divided by 9, just plug that into your calculator, or you could do the 5 divided by 9 first. Doesn't really matter however you choose, but the answer that you're going to get here is about 30.56. All right, you should get something like 30.555556, and I just rounded that to 30.56. All right, so again, pretty simple. Just use the formula, take the temperature in Fahrenheit, plug it in, follow the order of operations rules, which you would do, which are PEMDAS. Please excuse my dear Aunt Sally, and that's a lot more important for the math section than the science, but for a question like this, you do want to know how to do this PEMDAS. All right, so look for some of my math videos where I explain that. I'll put a link to one down below here, but anyway, yeah, you would do the 87 minus 32, and that's going to be 55, so I just rewrote the question here as 55 times 5 over 9, and that gives us about 30.56. All right, if you got that, give yourself an imaginary or a real round of applause, and we're going to keep rolling. Okay, next question, and you'll notice that the format looks a little bit different here, and I did that to try to get the diagram on screen here, but basically this schematic is of photosynthesis, and I want you to use it to answer this question, which is, which of the following is false based on the information provided in the diagram? A, sugar is synthesized from carbon dioxide and water. B, during the Calvin cycle, carbon dioxide is captured and converted into sugar. Or C, light energy is converted into chemical energy that gets stored in sugars. Or D, water is released as a waste product. All right, so go ahead and pause the video and try this out on your own. Okay, so you might remember some of this from when we were looking at photosynthesis early in the video, but try to just use the diagram here whether or not you remember it, all right? Photosynthesis, again, is a very, very big topic that you'll want to know for GED Science, and also you're going to want to learn how to understand diagrams and charts, so this question is going to be very valuable to you. So let's just go through these step by step using process of elimination. And remember, we're looking for which of the following is false or not true. So A, sugar is synthesized from carbon dioxide and water. Well, let's look at what's going on here in the question. So we see that water and carbon dioxide are going into the reactions, and we see that sugar is being given off here, right? So the arrows pointing away from the reactions are sugar and H2O. So we know that what's being given off here is oxygen and sugar. And so yes, we can say that A is correct. Sugar is synthesized from carbon dioxide and water. B, during the Calvin cycle, carbon dioxide is captured and converted into sugar. So let's look here at the Calvin cycle. So the Calvin cycle is called the dark reaction. All right, I'm just going to write dark here and reaction, or XN. And the reason it's called the dark reaction is because it does not need light. All right, so the Calvin cycle is your dark reaction. All right, whereas the initial reaction in photosynthesis is called the light reaction or the light reactions. Okay, so photosynthesis can really be split up into two different phases. We've got our light reactions and our Calvin cycle. Okay, and so basically just know that the Calvin cycle does not require light. And so what's happening here is CO2 is being captured, and indeed we see that CO2 is going into the Calvin cycle and sugar is coming out of the Calvin cycle. So yes, this is correct. During Calvin cycle, carbon dioxide is captured and converted into sugar. Okay, let's look at C next. C, light energy is converted into chemical energy that gets stored in sugars. So this might be a little bit harder to see from the diagram, but if you really follow what's going on here, it's not that hard to see it. So light energy is converted into chemical energy that gets stored in sugars. So let's look here at what's happening. So we see that our light energy is right here. So sunlight is going in here to light reactions, and what's coming out of the light reactions? Well, I want to draw your attention right here to what's being produced here. This is ATP and NADPH. And what I want you to know is that these are forms of chemical energy. Okay, so the ATP and the NADPH are going to provide reactions that drive they're going to provide energy that drives the Calvin cycle reactions. Okay, so the NADPH and ATP are they're energy. Okay, they are energy that drives the Calvin cycle. So what's happening here is that we've got light energy that comes in from the sun, and that is converted into chemical energy in the form of ATP and NADPH, and then that powers the Calvin cycle, and yes, eventually all this energy is going to be stored as sugar. All right, very important to know. So I'm going to cross C out here. And so by process of elimination, we already know that D must be false, but let's go over it. Water is released as a waste product. Well, what's going on here is that oxygen is a waste product that is released. So you don't really have to know that. So you might look at the oxygen, you might look at the sugar, and you might think, well, these are both products. How do I know which is the waste product and which is, not the waste product, which is the desired primary product? Well, you don't really have to know that. All you have to do is you have to look here and see that, hey, water is going into the reaction, and O2 and sugar are being produced. So they're being produced or given off. So water is not being released. We know that water is going into the reaction. And remember, water and carbon dioxide react in the presence of light, and they produce sugar, and oxygen is given off as a byproduct or a waste product, whatever you want to call it, and that is photosynthesis. So let me cross this out. And now I'm just going to take this a step back here and okay, because I wanted to just cross D off because D is false. Now, A through C are correct, and these are all good points to have down in your notes about photosynthesis. All right, and this diagram here is just important to understand and be able to follow the logic. Again, what's going on here is we've got our water and CO2, and in the presence of sunlight, all right, the light energy is going to be converted into chemical energy, and the chemical energy is going to be stored into sugars. All right, now this is oversimplified. Okay, there's a lot, believe me, a lot of details here that we could get into in this question, but they're not really that necessary. I just want you to see the basic points here. All right, now let's keep moving. Okay, here's question 10. So I'm going to read the question here, and then I'm going to show you the answers so that we can get them all on the screen here and we can see everything okay. So question 10 says, in the 4th century, scientists believed that the Earth was the center of the universe and that the sun rotates around the Earth. This model is known as the geocentric model. The model was supported by the observation that the sun appears to revolve around the Earth once a day when a person watches from the sky from anywhere on Earth. Additionally, the Earth feels stationary from the perspective of observers on the Earth. Nicholas Copernicus developed the heliocentric model in the 16th century. Copernicus proposed that the sun is the center of the universe and that the Earth orbits the sun. Shortly after, Galileo Galilei used the telescope to gather evidence confirming that Copernicus was correct. Today, scientists reject the geocentric model and hold that the heliocentric model is correct. Okay, so, get a chance to look at that right now while I bring up the answers, and they are kind of small, so let me pull that off the screen there, but if you need that, you can just rewind the video and just pause it on that and just take your time reading it. But anyway, so let me pull these questions up here on screen, and again, I'm doing it this way because I want to make sure that we've got room to read here. Okay. So the question is, which statement most accurately summarizes the passage? And so you can pause the video now, and remember, if you want to go back and you can look at the prompt again, just pause the video and just rewind it just a little bit. All right, and so let's work through this now. So which statement most accurately summarizes that passage? So A, in the 4th century, scientists believed that the geocentric model was correct. Okay, so far so good. And then it says, scientists today still believe that the geocentric model is correct and reject the heliocentric model. So A is incorrect, and the reason that A is incorrect is because it's actually the opposite is true. B, in the 4th century, scientists believed that the geocentric model was correct. So far so good. Today, scientists now believe that both the geocentric and heliocentric models are correct. All right, let's cross B out because B is also wrong, and this just comes right out of the passage. So with these kinds of things, the trick really is to just read the passage and then make sure that all parts of the statements are correct. All right, so what I'm doing here is I'm reading that in the 4th century, blah, 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 that first part, and we're making sure that that's correct. And if that's correct, we then check the second part, all right? So like in answer C, it says, in the 16th century, scientists believed that the geocentric model was correct. And that's incorrect, right? Because remember that it was in the 4th century when they believed the geocentric model was correct, and then it goes, but they believed that the heliocentric model was correct in the 4th century. So that's incorrect, because remember, it was the other way around. They thought it was the geocentric model, that's what they thought in the 4th century. Then around the 16th century was when Nicholas Copernicus started to put forward the heliocentric model, and then that was later confirmed to be correct. All right, so D is the last one standing here, and D is the correct answer. All right, so hopefully this one makes sense.